Alright guys, today we are going to cover section 12.1. This is on adding and subtracting matrices. So the first thing we need is we need to know what a matrix is. Okay, so here's your definition. A matrix is numbers and or variables arranged in rows or columns. Okay. So this is what a matrix looks like. We've got brackets around it. That's how we know it's a matrix. This is matrix A. Matrices are always named with a capital letter. Okay? So if you take a look at matrix A, it has two rows that go across the page, and it has three columns that go up and down, just like the columns on your house. Okay, so two rows and three columns. The way you write this is it is written as A, and then as a subscript, you have 2 by 3. You always put the rows first by the number of columns. Okay, this is not a multiplication symbol. This says rows by columns. So when I ask you for the dimensions of matrix A, it is a 2 by 3. Sometimes instead of asking for the dimensions, they will ask for the size of the matrix. That's the exact same thing. The size is also 2 by 3. So what we're going to take a look at is how to add and subtract matrices. So the very first thing you need to know about adding and subtracting matrices is they must be the same size. Okay, and all you're going to do is just add and subtract the corresponding elements. Okay, and when I say the corresponding elements, that means each individual entry in the matrix. So 4 is an element, 9 is an element, -1 is an element. Those are just the individual numbers or variables. So here, for problem 1, they want me to add, in part A, they want me to add matrix C plus matrix D. Well, first thing I want to look at is, are they the same size? Well, matrix C has 2 rows and 3 columns, so it is a 2 by 3. Matrix D also has 2 rows and 3 columns, so it is a 2 by 3. So I can add these and I can subtract them. What you're going to do to add them is you're going to take 3 that is in the first row, first column, and add that to the 1 that is in the first row, first column of D. So here's what you are doing. You're doing 3 plus 1, and then you're going to slide over on row 1, go to column 2, and you will do 2 plus 4. Stay on row 1 and do column 3, that is 4 plus 3. Now we're going to move down to row 2. -1 plus -2, 4 plus 2, and 0 plus 4. Okay, so now I'm going to go ahead and add those to get our answer. Okay, so C plus D is equal to, on the top row, it is 4, 6, 7. On the bottom row, it is -3, 6, 4. And this is your solution, or this is matrix C plus matrix D. When they want us to subtract them, we're going to follow the exact same patterns, only we're going to subtract instead of add. So I'm going to start top row, column 1, 3 minus 1. Okay, move across on row 1. We'll do 2 minus 4. Keep going on row 1 and have 4 minus 3. All right, row 1 is finished. Move down to row 2. Negative 1 minus negative 2. And then I have 4 minus 2 and 0 minus 4. So when I go ahead and finish simplifying all of that, C minus D is equal to, top row is 2, negative 2, 1. The bottom row, minus a negative becomes plus a positive, so that will be 1, 2, negative 4. All right, next we have a definition for a zero matrix. And in a zero matrix, every element is a 0. And a zero matrix can be any size. Okay, doesn't matter how many rows or columns you have, as long as everything in it is a 0. Next, we need to talk about an identity matrix. Now, a couple things that you need to know about an identity matrix. The first thing is it has to be square. Okay? Now, what is a square matrix? Well, it is a matrix that has the same number of rows and columns. Okay, so it could be a 2 by 2 or a 3 by 3. As long as your rows and columns are the same, that is a square matrix. So what an identity matrix looks like after it's square. Second thing we know about it is that it has the number 1 or 1s on the diagonal, and 0s everywhere else. Right, so we're going to look at a couple of these. If I start out here, this is a 2 by 2. That is an identity matrix. Now, the thing is, your diagonal could also go the other direction. So it might look like this. Now, let's take a look at the 3 by 3s. So you can see there that I have 1s on my diagonal, everything else is a 0. But once again, your diagonal could go the other direction. This is also a 3 by 3 identity matrix. So now we're going to talk about a matrix equation. A matrix equation is simply an equation involving one or more matrices. So here is my matrix equation. I have a matrix plus A, and this is going to have to be another matrix because you can't add a matrix to just a letter or a matrix to just a number. It's got to be a matrix plus another matrix to get this matrix. Well, we're going to solve this equation just like we would any other equation. If something is added to a variable, I want to subtract this from both sides to get that variable by itself. So what I'm going to do is I'm going to subtract this matrix from both sides. And what that will leave me with over here, when I subtract something from itself, that gives me the 0 matrix. So it's like it's not there. And I'm left with the A. On this side, I'm going to subtract, just like we did on the first page of notes here. Subtract the corresponding elements. So 8 minus 1 is 7. 11 minus 0 is 11. 9 minus 12 is -3. Top row's done. Now we're going to move down to row 2. -5 minus 3 gives me -8. 5 minus 5 is 0. 2 minus 9 is -7. Second row's done. Now let's go to the third row. 10 minus 7 is 3. 7 minus 8 is -1. 8 minus -2 is 10. So now we have solved the matrix equation, and this is your solution. This is matrix A. Right. So now I have another one for you to try this one. Okay, you go ahead and try it. You may want to pause because I'm going to go ahead and start working on it here. So there is my solution for X. Next, we have scalar multiplication, and this is basically just the distributive property for matrices. So if they put a number in front of a matrix, this number is going to be distributed to everything in the matrix. So let's do one row at a time. 2 times the entire top row will give me 2, 16, 1. And 2 times the entire bottom row is going to give me 6 over 4. That reduces to 3 halves. 2 times 0 is 0. And 2 times -6 is -12. This is your answer. So now we have another matrix equation to solve. This one's in your book on page 768. It's not part of the examples. It's number 12 in the homework set. We're going to start out the exact same way we did the other. We're going to take this and subtract it from both sides. But what that's going to leave me with is negative x, and then I'm going to have to take care of that negative. So 11 minus 2 gives me 9. 3 minus 1 is 2. Negative 13 minus negative 11 is negative 2. 15 minus 0 is 15. Negative 9 minus 2 gives me negative 11. 8 minus 1 is 7. But now, I've got to get rid of this negative 1 in front of x. So here's the thing. There is no division rule for matrices, but you can multiply or do scalar multiplication. So all I'm going to do is take and multiply this side by negative 1 and this side by negative 1. And that will give me a positive x, and then I just distribute this negative 1 to everything in here. So I get negative 9, negative 2, 2, negative 15, 11, negative 7. And this is your solution. So now, next, we're going to work with equal matrices. And our definition for equal matrices, this is a matrix, or sorry, not one matrix, but two matrices. Matrices in which all corresponding elements are equal. So what I want you to see here is that the first row, first column here is a 9. First row, first column here is a 9. Those are equal. 3x plus 1 has to equal 16. Then I have 2y minus 1 has to equal negative 5. And then finally, 10 is equal to 10. What they want me to do is find the values for x and y that make the equation true. So I'm going to take my 3x plus 1. I know that it is equal to 16 because this whole matrix equals this whole matrix. So I can use this equation to solve for x. Subtract 1 from both sides and divide by 3. X is 5. Now, because these are equal matrices, this element is equal to this element. So I know that 2y minus 1 equals negative 5. So let's go ahead and move the 1 over. So add 1 to both sides. 2y is negative 4. That means y is negative 2. And that is the end of section 2.1. Sorry, 12.1.